Welcome everybody. Welcome to this piloting innovation workshop. And thank you very much for attending. I hope you can hear me well. And we have a very interesting schedule for the next 2 hours and a half. And we hope it will find you interesting so you can have a look to the latest development and also what are the main value proposition and use cases that we are thinking to explode hopefully after the project. And we need your support in order to select and to get feedback for all of them. So this is we hope it will be an interactive session. We have a set of tools that will allow to interact during the session, and we will guide you during the workshop in order to get also your feedback from all of you. So first of all, because maybe some of you don't know about what is piloting, we're going to have a short introduction about piloting project. So let me just share screen. Okay. I hope you're able to see my screen well.
Yes.
So I said before, this is piloting project. This is a Horizon 2020 funded project by the European Commission, and the main motivation of this project is because the infrastructure in Europe are aging, are getting older and older, and for example for the refineries and also the civil infrastructure, and they are becoming deteriorated. So we need new set of technologies and tools in order to increase efficiency of the inspection methods. So we can do it cheaper, and then we can do these inspections more frequently. And we really believe that robotics and artificial intelligence are key technologies that will allow to reduce the cost, reduce the time of inspection, make them more efficient, and also increase the quality of the inspection that will allow to increase also the rate, maintaining the cost or even decreasing them of the inspection in this type of infrastructures. It's also true that inspection maintenance is a big market, and we really think that Europe and the industry sector in Europe will have an opportunity in order to become a leader, a worldwide leader, international leader in applying robotics, artificial intelligence in inspection and maintenance sector. So the main objective or purpose of the project is to develop solutions, robotic solution, artificial intelligence solution with a high level of autonomy. So you don't need very skilled pilots or operators that will allow to complete the inspection procedures in less time, reducing costs, also increasing the safety of the operators, and improving the quality of this inspection, the data that we obtain in a fully digitalized system. And also it is important that piloting is very focused on the end users' needs, and that's why also we're having this type of workshops, okay, in order to get the feedback from the industry and the feedback from not only from the industry end users that are part of the consortium, but also outside of the consortiums. So what are the main challenges and objectives? So the main three challenges is, of course, of any inspection, as I mentioned before, we need to reduce inspection costs and also the downtime, the time that we cannot use the infrastructure. This is very important. So you can complete the inspection without disturbing the minimum, the regular operation of the infrastructure. The second challenge is to produce reliable and high quality inspection data. And the third one is increase the safety of the personnel, because many of these operations, you know, they are at work at height or, for example, in dangerous scenarios, environments. So in order to cover these challenges, we have 5 main objectives in the project. First of all, we are working to move forward to increase the TR level of the robotics technology and artificial intelligence up to TR 7 in this project of different type of robotic solutions, aerial, ground, and crawlers. Also, we are developing what we call the piloting inspection maintenance platform, which is a set of software that allows, facilitates the use of robot in inspections and also facilitate the handling of all the data that are required from planning to analysis of the inspection data in a fully digitalized way and fully integrated with the robotic system. Of course, in order to reach TR7, we need to demonstrate the benefits of the piloting project through large-scale pilots. We have just concluded the first iteration of the pilot experiments. In the project, we are covering scenarios in refinery, in tunnels, and in viaduct bridges. This year, we just concluded the first set of experiments in these 3 scenarios in Spain, France, and Greece. And next year, by the end of next year, we will have a second set of experiments. And the last 2 are related to, first of all, overcome the current barriers so we promote the use of robotics in inspection maintenance and also support the promotion of European robotic solutions so they can become a leader, international leader in inspection and maintenance applying robotics. The consortium, so we are piloting project is formed by 13 partners from 6 different countries. It's important to highlight that we cover the whole value chain. We have 3 end users: Chevron for the refinery, Ferrovial for the viaduct, and Inatia for the tunnel. We have a service provider, IP Plus, for inspection. We have 3 companies related to inspection and maintenance are developing inspection and maintenance technologies. Wago Technologies, Quaset, and Ilecom. And then we have a number of universities and research centers like UC Seville, ICCS, and also a research center like Sintef, CATEC, and then also ETH Zurich. So what are we covering in this project? So we explained the main objectives, but why are we really covering? So as you probably know, inspection and maintenance are very dependent of the use cases. The solution are very dependent on the use cases. So after several iterations at the beginning of the project with end users, we decided to focus on these 10 use cases. For the refinery, we have contact inspection with drones of large infrastructure inspections, inspection of pipes using a hybrid robot that is a mix between aerial and ground robots, vessel inspection using a crawler, and ground monitoring using a ground vehicle. For the viaduct inspection, of course, it's a work ahead. We are going to use drones or UAVs or aerial robots. So we have a visual inspection that is very important to have a first assessment of any type of defect that may have. And then we have the inspection of the bearing, which is a very particular aspect that has a lot of value for the users. The installation of sensors at different locations that's difficult to get to. And also, in order to complement the visual inspection, the surveying targets installation. And finally, for the tunnel inspection, we have the general inspections that we will make use of UGV and the local inspection that is a mix between the UGV and an aerial robot. So for all these 10 use cases that we are covering in piloting, all these 10 use cases, which is a high diversity, we are going to use and we are adapting a number of robots. So we have a number of aerial robots, ground robots, and crawlers and hybrid robots that you can see here. It's important to highlight that for all of these robots, we are targeting a high level of autonomy, so it makes easier to operate and also facilitate their interaction and also decrease the training needed for the operator. And for all these robots, we are integrating all these robots, what we call the pilot inspection maintenance platform, that allows, as I said before, it has a visualization portal, and then it's a set of software that facilitates the planning of the inspection missions, the data, the planning of the specific and also the monitoring of the execution of the mission by the robots, and also the analysis of the data. So it's a set of software that complements the robot and integrates the robot in a common framework, so you can easily integrate for future use cases and for future robotic systems. And since we are covering, as you can see, a large number of use cases and a large number of robots, it will, we hope that in the future will facilitate, also will be a key element to boost to the use of robotics in inspection maintenance. Actually, we plan to open source this platform by the end of the project. So if you are interested in that, you can contact us. So that was basically the introduction. It was a very brief introduction. And then I'm going to pass the word by our colleague Henrik, that is also co-organizing this innovation workshop from Sintef. And then we can continue with the workshop.
Yes, thank you very much for that introduction. So I will start sharing the screen, as you hopefully will see, and then we will have presentations of 10 different value propositions. And at the end of each presentation of a value proposition, you will be able to see and give feedback on this Miro platform, and you should have received an invitation so that you can enter and see this platform. And on that, you will then be able to just put your assessment and your advice for specific things that you would see as good or potential for improvements on each of these value propositions. And yeah, I think with that I will just leave the floor for the first presentation, and I hope you can take control of the presentation so that you can control and move forward with the slides. Otherwise, you just have to ask me to do it. Do you have?
I think we can just tell you next.
Yeah. Okay.
So I'm not.
Yeah.
Can you see or not the presentation? Can you comment your value proposition? Can you hear us?
We don't hear you or not.
Can we move to the next one, and maybe we can?
Yeah. So we move to the next, and then which would be the mission planning interface. And then we see if we can get one or later.
I think this is Moritz.
Yes, hi, Antidio. This is Morris. Can you hear me?
Yep.
Okay. Hello, everybody. Welcome to that presentation of the mission planning interface. Can you just go one slide forward, please?
Yes.
So Basically, what you see is on the right is kind of the information you usually have when planning jobs in refineries and other infrastructure for inspection. It's basically a drawing and then some hand added or maybe computer added information on where to inspect what and do some basic planning. It's pretty difficult, and of course also it varies from asset type to asset type, and it's a lot of work to do this kind of preparation. And the other thing is also when you later want to follow through with the inspection, it's quite tedious to figure out from the drawings like where you really need to do the inspection based on the planning. So basically, what you see here on the jobs list, basically you need to determine like where to work and what to do and what the owner wants to be inspected and what has to be inspected by code. Then information about previous inspections need to be gathered. Usually it's in printed version, sometimes written documents, sometimes sketches on drawing. And then basically the tools need to be selected, and the type of report that later needs to be made also needs to be prepared. I mentioned a few of the pains already in the introduction. So it's on paper usually. Sometimes the data format is not consistent. It can be paper, it can be files, it can be electronic. It's difficult to access. Very often having the access requires having access to some like actual file cabinets. And as I already mentioned, when you do the preparation, you don't really have a direct link between the preparation, the execution, and the reporting. You kind of, you totally rely on the person executing it in accordance with the preparation, and also the person who prepares the reporting to correctly remember how the execution was performed. And furthermore, very often some of the planning has to be done when on site already, maybe due to missing access to information or other of such problems. The report that is usually generated after inspection is of course based on the data gathered during the inspection. Very often information about location and type of problem, type of detection is stored in handwritten notes, and let's say pictures taken by cameras or signals recorded by ultrasound sensors need to be correctly associated then based on proper note taking. This is time consuming and also error prone. So can you go one slide forward, please? Thank you. The piloting solution here is kind of a centralized repository for like where you have online access to a 3D representation of the asset under inspection. How these representations get to exist, that is the topic of the previous few slides, so I will not go into details there. But what you see here is on the left, this is a very simplified one, but they're usually a bit more complex. But let's say this is a pressure vessel, and on that pressure vessels, there are certain areas that need to be inspected in certain ways. For instance, there could be spot locations where a thickness reading should be performed. And of course, it would make sense that every time this asset is inspected, the thickness reading should be taken in the same area. Otherwise, comparison over time is very, very difficult. So You see here on the left how these things can be improved if you have a 3D representation where the location is very precisely stored. So now I will go through the slide a little bit. I already mentioned the central repository that helps access to asset information as well as to inspection results created in earlier inspection, and also to mission data. The big benefit of the piloting approach in this is that once an inspection is planned in this type of 3D tool, it can be exported directly to the inspection tool. And the inspection tool can either autonomously already perform parts of these inspections, or it can guide the inspector through the process so that basically the entire mission is executed as planned, guided by the tool or even executed directly by the tool. It depends, of course, on the tool and its capabilities, but in many of those tools that are used in the piloting project are able to autonomously move around and follow these inspection plans. And as mentioned before, that will of course close the gap between the results of previous inspections and the current inspections, and will allow for very accurate tracking of variations in the asset, for instance, like thinning of the wall or surfaces corroding or stuff like that. It also has the benefit that on site there is no planning needed, so that basically that will reduce downtime. It will reduce paper handling, and it will also allow for automatically creating inspection reports. The last point is, of course, yeah, it's basically guarantees the consistency between the planning and the execution. On the cost side, of course, that will, yeah, mission planning phase will be streamlined. It can be done in the same way for all the different assets. You don't need to rely on different methods for the planning, and it will of course reduce downtime purely by removing the need for mission planning while on site, and also removing the need for the tool operator to spend a lot of time with notes and with figuring out where to go next and what to do next. I think that was it from the slides, Antidio. Am I right?
Perfect.
Or is there another
thank
one?
you. Well, thank you very much, Morris, because we have a tight schedule. So
Yep.
Thank you. So Henrik.
Yes, so I can instead share the screen with the Miro platform, so you can see how that should
So to
work.
all the attendants, you should have received, but maybe you can copy it in the chat, Henrik, just in case.
Yeah,
A link with a collaborative tool that will facilitate to get your feedback. So,
yes.
so
Where
this
do I
tool
get
will
this?
allow to for all of you to put comments on the different value proposition that we are presented. We just presented the first one. Okay, this is the link that is in the chat. And
I'm
then
not sure if
maybe,
everyone received the link.
yes.
So
So if you can just share the screen with the link.
so are you get you see the right screen, the one with the
Okay, no,
I'm not
no,
sure
we
which
can,
screen you're seeing, but
no, the one with the OneNote.
that's the wrong screen. Yeah.
Let me check 1 second if I can.
Okay.
1 second.
Now you get the correct screen now.
No.
Stop
Check.
share.
Okay. I can share the screen. Let's see. Yeah, now we can see it. Not full screen, but we can see it.
Okay, then I can just take it into full screen, and as you here you can see the different value propositions, and
Yeah.
it's yeah. No, it's zooming a bit strange. I think it's basically struggling a bit with too many users maybe, but the idea is basically that you can, well, either you can just leave a comment, or you can grab one of these notes and or these post-its and start typing your comments. And here we have we use this axis for whether it's something you need to improve or something that you think is good, and also on the other axis, if you see it as low value or high value. And if you don't see exactly where to put this, you could also put it just next to the a bit outside of this. That would also be fine. But you see we have this frame, so for the value proposition 1, the quickly build 3D asset model, I just put this example, and now we should actually be at number 2, which is this mission planning interface that was presented. So here, we have, well, it's a bit slow, at least for me, but I hope it's working better for you. So here we have, you see someone has put in a comment.
So it's as easy, you can see, we can put here a note, okay, and then we can just write something like about, for example, high value, but can be improved. So extend to vehicles such as something like that.
Yeah.
Okay. So please, everybody, have a look to it, so you can put some comments while we are presenting the different value propositions. So I think, Henrik, we can go to the next one.
Yeah.
I don't know if Arnold, can you, it's not working your mic?
Can you hear me now?
Yeah, no, now we hear you. So I can go back to the first presentation. Yeah.
You can speed it a little bit. Perfect.
Yeah, okay, I'll try. Good morning, everyone. My name is Arno. I'm from Quasset, and we are doing the intelligence and visualization portal in the context of piloting. This value proposition is about quickly building a 3D asset model, and it's not in full screen anymore, the slides, but so why do we want to do that? So the customer profile that we're targeting here is that the job is to build a 3D model of physical assets. And we see a lot that there is an acceleration of the use of robotic solutions for inspection and maintenance, and also in terms of digitalization of the asset integrity management. And the 3D model is a central piece in that workflow. And the main problem is that for first for aging assets, digital twins typically do not exist, and at best you have just the drawing of the as-built assets. So that's what you see on the right there. And if you have such a drawings, you need to understand what it is first, but also building it with a traditional CAD program is complex, costly, and time-consuming. And you also need to have a lot of technical skills in terms of 3D modeling and engineering knowledge. And such an application, such as Maya, for example, cannot be easily integrated with existing custom applications, and they also typically requires a high-end desktop hardware. So how do we solve that? If you can go to the next slide. Yeah, so what we have here is the product that we already have developed and started to sell. It's called Asset Builder, and it is essentially a web-based drag and drop modeling tool that allows you to quickly build a certain type of assets. And the way it works is that we put a lot of domain knowledge into the software, so that it makes it very user-friendly and also easy to learn and adopt, even for non-technical experts. And it's essentially just like building an assets from a Lego. The Lego here are the parts, and these parts depend on the specific type of assets. And the real gain that you're going to get out of this is that you can build a digital twin of large assets from scratch within minutes. And that results into sensibly increasing the productivity, but also it would reduce the cost of training for specialized software. In addition, we have this product either as a standalone software as services, or it can also be integrated into an existing custom applications. If you go to the next slide. Okay. As I said, building those models is basically like assembling Legos, and those Legos are parts which are specific to assets. And what we do is that you need to know exactly how those parts connect to each other. And if you change some parameters, basically the whole assets will update. And for that, you need to know exactly what kind of assets we are building. And at the moment, we are supporting 3 class of assets: pressure vessels. So that's the one that you see in the previous slides from Moritz. We can build piping assets as well, and we can build storage tank assets. Those models are going to be used to share dimension and geometry of the assets. So that's in the whole line of digitalizing your assets. In the context of piloting, as you saw from the previous slides, we are using those models also to indicate the inspection locations where a robot had to go to. It also serves as a reference for some of the robotic navigations. And we can also use these models to display the inspection results in context of the 3D assets. And yeah, I think that's in short about this value proposition.
Thank you very much. Yeah. I can see that there are some people putting some notes on the mirror. For example, there's one person that put that it could be interesting to integrate with BIM models. Thank you very much. So please, if you see that something that can be improved, something that is low value or high value, please use the ticks on the mirror so you can send us your comments, so we transmit your comments in an easy way. Thank you. So we can go to the next one, Henrik.
Yes, so I think it's Christos maybe. Mission planning interface. Oh no,
It was already.
Yeah, the piloting INM platform.
So hello everyone, I'm Christos, and this value proposition discusses the piloting, inspection and maintenance platform. So next slide, please. The inspection at various infrastructures such as refineries, bridges or tunnels includes mainly three tasks. And first of all, the organization of a planning in order to perform an inspection at the respective infrastructure. Second, the collection of different data sources, which may have to be digitalized or even to be transformed in an inappropriate format in order to be stored and evaluate. And finally, the storage of this collection data and the evaluation of them. During the inspection process, the companies have to collect all the inspection data and also deal with the heterogeneity of them due to different inspections and robotic systems. And also the absence of an automated process means extra effort for collection, harmonization and organization of this data. Therefore, the process of the inspections and the transformation of the data into available digitalized knowledge may be a costly and a time-consuming process. And also sometimes there also may be inconsistencies in the reports of the inspection results or errors on the information results due to also to inspectors' subjective judgment. So next slide, please. So we here introduced the inspection and maintenance platform, which is a framework that can allow the pilot end users, as well as any engineering inspection companies, to perform complete inspection tasks in critical infrastructures. Moreover, this platform offers connection with a variety of robotic systems, and it also offers functions such as data harmonization and storing of this data. So the platform consists of three components. The first one is the general robot control station. This component is responsible for establishing a connection with every robotic system and also command the action to the robotic systems in order to perform the inspections and various infrastructures. We have also the data management system, which provides authorized functionality to the users. The main functionality responsibility of the DMS is to manage the data of the inspection. In other words, DMS is capable of retrieving, indexing, and storing any data received from robotics or static legacy systems during the inspection process. So the user can have an easy access to this data. And finally, we have the data distribution and harmonization layer. This component is in the middle of the other two, and it's responsible for bridging the communication between the GRCS and the DMS. And it also, its purpose is to allow the transfer of data between between the GRCS and the DMS. And also, one more functionality of DDHL is the transformation of the heterogeneous data in the appropriate format in order to be evaluated and examined by the end user. So next slide, please. So this solution, what it offers is that now the inspection data can be easily handled as they are digitalized automatically, and also they can be also very easy accessed using, for example, the DMS. The inspection missions can be performed in a safe environment, allowing the remote navigation of various sensors, and the inspection data are accompanied by time and location indexing, allowing the localization and detection of any issues for the end user. And finally, inspection data such as the data from robotic systems, or the AI results, or the inspection documents will be given in a standard format, ensuring the information coherency and the prevention of any data loss and misinterpretation of the collected data. So the game creators from this platform is that now this platform provides a solution that can incorporate and communicate with a variety of robotic systems, such as aerial, crawler, or ground robots, to process different kind of inspections, so that data can be organized and collected for any industry scenarios, such as refineries, viaducts, and tunnels. The platform also offers a better representation of the inspection by monitoring this process and giving an improved and more accurate and safe understanding of the infrastructure. It can also provide more accurate results, avoiding information inconsistency through the automated generation of the reports and data collections following the appropriate formats. And finally, the inspection process can be executed more efficiently. And in other words, with this platform, we can increase the safety of the personnel and reduce the cost and the time for collecting, harmonization, and storing the data. So this is about this value proposition.
Thank you very much, Christos. Please, we are in value proposition 3, okay? It's in the first row, okay? For example, here where is Natalie Kafka, also myself, Miguel. So there's one person that put here that increased safety, reduction of data loss, consistency are very significant features. Thank you very much for the comment. So please put your comments, something that can be improved, something that you think that is high value, the good aspect, the aspect that can be improved, everything like that. Imran, you are putting some notes, great, thank you very much. So please complete what we are presenting. Perfect. Yeah. So I think we can continue with the next one while people are putting some comments. We can leave maybe 1 minute. Henrik?
Yeah.
I think...
Bye. Yeah, I will move forward to the next because I think I have it in the wrong order. So.
Good.
Let me check.
So the next one is the Jenny robot control station. Perfect. So I think thank you very much. Okay. Please also, you want to comment about the previous ones, that's no problem. You can comment the previous one. Number one, that was the 3D asset model that was presented by Arnaud. Also the mission planning interface for the robot systems, the tool that allows us to plan in detail the trajectories, the piloting inspection maintenance platform that was just presented. And now we go to frame 4, generic robot control station. So, so next slide, please. So, from our experience, if you are a service provider, okay, of inspection, you will need to operate hopefully in the future, a diverse number of robots. Maybe you need drones or aerial robots for doing inspection and height. You need maybe crawlers for indoor inspection, for example, of a vessel. You also may need also to use ground robots. So you will need different kind of robots with different functionalities. Also because from our experience, the robot is a tool to gather data. And usually the environment to get the data is very specific. You need a robot adapted to this specific scenario or environment. So usually what this creates, the use of this diverse number of robots create a number of pains to the service providers. First of all, that you have very different interfaces and control systems for each of the robotic vehicles, because they usually involve different vendors, different companies with different type of interfaces and so on. And also, it's difficult to train because of the diversity operators for all the robots, and also to find an operator with the required skills to operate such a robots, because they are very different. So this is a very important pains that we have detected. Next slide, please. So in order to try to overcome these pains or to decrease them, we have I think the video is stopped, but I don't know if you can run it, Henrik. You click on them. But basically, what we have now is working perfect. So basically, what we have created is a common robot control station software for all the robotic systems. So you will have the same robot control station software for all the robotic systems. It will be used for planning of the mission and also to supervise the execution of the mission. And it has an open protocol to communicate with the robot, so it's easy expandable to new robotic vehicles. We have already integrated with 10 different robots from ground, crawlers, and aerial. So it's a large diversity. So we have demonstrated that you can use this robot control station with a large number of robots. So we are pretty sure that you can use it for your own robot in the future. And also the good thing is that it's already integrated in the piloting inspection maintenance platform. So then the upload of the acquisition of the data and the upload of the data, at least the one related to the robot, it will be straightforward. So that also facilitates the integration of the robotic system or the robotic vehicle into the piloting inspection maintenance platform that we just presented. Next slide, please. Okay. Well, here we have another view of the software. Okay, so you can have a look. So it can be used first. The first video was for planning, and the second is to supervise the execution of the mission. Okay. At least I cannot see the video very well, but at least right now for me it's stop. But I hope you can see more or less have an idea of what is the software about. Good. Now it's working. So this was, for example, an inspection of robot, visual inspection of a pilot using an aerial robot or a drone integrated in this general robot control station. Next slide, please. So we have seen first the pains. What is our value proposition? This unique software you can plan and supervise execution of a large number of robots. So what we think this add, what are the values that it has? So first of all, is it's add a unified, a standardized interface for the complete fleet of robotic vehicle that everybody may have. So, and this is very good because you will have one software for all your roads to supervise and plan the missions. And secondly, of course, it will reduce the training time of the operators, of the pilots, since you're using the same robot control station for all the robots. So it will save you money and will facilitate that even if you have one person that is managing one robot, then you can also switch them because, for example, you need to change the schedule or whatever. In terms of game creators, it will, of course, it will reduce the training costs, the training time when a new robot is incorporated, because, for example, you are going to, the operator will start a new type of inspection, and you need a new type of robot. Also, our robot control station can be installing a large variety of devices. It could be a tablet, a laptop, etc. And you have a standard interface, so you are not tied to a unique robot manufacturer. So this is very good. So even if you don't change the robot because you are changing the type of inspection, imagine that you are specialized in tanks inspections, but you now change the vendor. If you use the software, you will maintain the same interface. You just need to integrate the new interface, the new robot to the existing interface. And then you are not, your interface with the robot will be the same, so it will be much easier to change the vendor. And also because, for example, there is a new company that is cheaper, the robot, or the one that you already have disappear, whatever. So give you much more flexibility. So I think within these are the main game creators. Okay. So that was the explanation of the value proposition. I can see here in the mirror that some comments. Okay, for example, there's one related to the good thing is the easily integrated new vendors helps test new road with less effort. Thanks for it. Also, there's another comment saying that incorporating all different roads, models, and manufacturers into one user-friendly interface is definitely a huge advantage of the proposal. Thank you very much. So please, if you think about something that maybe we are missing, any other value or any other things, for example, pain that we have not identified, or any game creator that we think you think is interesting, please add it. Maybe we can leave a couple of 1 minute so people can complement, put some other notes if you think this is something that you can. I hope everybody can access to Miro. I can see that a lot of people there. I don't know, Carlos, if you finally access to it. If not, please share your comments by the chat, using the chat. And yeah, let's check if there's more comment on the other. For example, yes, there is one comment of piloting inspection maintenance platform. If we can integrate with robot operating system, I guess this is ROS. Actually, it's quite easy to integrate with ROS because we actually using our protocol between the robot control station and the robotic vehicle is based on Mavlink, and then the integration of ROS with Mavlink is also straightforward. So actually, some of the robots they use ROS. So yes, we can integrate with ROS. But it's interesting that you put this comment because maybe we can highlight that our piloting inspection maintenance platform is ROS friendly, I would say. Okay. Okay. Good. Good. Yeah, this is interesting. In the quality 3D model asset, there was a comment saying that add visual notes for inspection, such as dangerous gases or other safety info, could be interesting as well. Or expand the model to infrastructures as a bridge, joints, or tunnels features. Okay, this is also very valuable. Thank you very much. Okay, Henrik, I think we can go to the next one. So we're moving to the GNS free area robot navigation in large areas. So next slide, please.
Yeah.
Okay, good. So what are the jobs that we are targeting with this value proposition? So as you can see in these pictures, there's a number of inspections, visual or also the type of inspection in, for example, in viaducts and bridges. Also could be in tunnels, but maybe in viaducts and bridges, that you need to work at height, for example, rope access, or you have to use some kind of machinery, large machinery. You have to cut the traffic, or it's very dangerous for the operators. So these are the type of works that we are targeting in this value proposition. So what are the pains? If this work is done manually by persons, this is costly and time consuming. Most of it is invested in accessing to the area of inspection. So the inspection itself is very fast. But reaching to the point so you can do the inspection is it requires a lot of money and time. And also it's a dangerous work, so it has a critical aspect on safety. If this work is done with a commercial drone, we will say, with the one that you can find, or the regular ones, I would say, you can find on the market, usually it's difficult to teleoperate or find pilots with the necessary skills, especially because below the viaduct or the bridges, you don't have good GNSS coverage. So that's most of the commercial drones, they are based on GPS or GNSS, GPS-based navigation. And one important thing, even there are some, I would say, drones that you can, they get stabilized quite well even without GNSS, for example, some DJI drones. There's one feature that we think is very important that we can add with this technology, with this value proposition. That with this technology, we can ensure you that if you come again to the same viaduct or bridge, you can navigate to the same position and take the pictures or take the measurements from the exact position. Okay, we will explain how we do it, okay, very briefly. But it's true that this is a very added value that at least from experience is very important for the different end users. So we can, it's not just that you can navigate without GPS, okay, maybe some drones can do it, but the real added value in our opinion is that you can come back to the same position and take the pictures from the exact same position, even 1 year later, 2 years later, 3 years later. Every time you come back, you do the same type of trajectory with the same type of inspection, so you inspect the same points. And then you can compare easily how the defect has progressed, or if there's a defect that was not before, and things like that. Next slide, please. So the value proposition you can see here is that we are able, as you can see in the video is not going very well with the zoom, but it's okay. So you can see here now at least from my side it's stop, but you can see at the drone how it can navigate or be able to operate below the bridge without any kind of GNSS, and do it without having to integrate or install any kind of infrastructure. Okay, this is very, very important in this sense. I don't know if the video, it was the idea that you can see that it's very, very high bridge once we move forward to the the video, but yes, you can see here that in order to access to this location to take pictures, you will need to or do rope access or a large machinery, and it's very difficult in that sense. So it's a high, dangerous and costly work that you can make it much easier with a drone. Okay. Okay. Let's see. I don't know. You can move forward to the video a little bit more. No. Okay, it's okay. So, what is the value proposition? The value proposition, I said there are two main things. One is the global localization. So we have a technology that allows to localize the drone, the aerial robot, with respect to the bridge of to the viaduct, always in the same global reference system. So you can come back to the same position anytime you need, even 1 year later, 2 years later, and so on. So this is very important in our opinion, and this is a key added value in this value proposition. Okay. Next slide, please. So, what are the pain relievers for the operators, for the service providers? So this GNSS-free navigation will allow autonomous operation, reducing the training and skill of the operators. Of course, if you can just need to draw a number of waypoints on the general robot control station, and then press run, and the robot will, from takeoff to landing, will do automatically, and every year it can do the same exact trajectory. This is very good because it has a high level of autonomy. It will make the operation faster, but we think even more importantly, it will reduce the skills of the operator. So the operator doesn't have to have special skills to take pictures close to the for example, to the surface of the bridge. And also this global localization system allows to take pictures of the same area anytime you require. Okay, that's it. So you can come back 2 years later, 3 years later. So at the end, the game creators are reduce the time to perform the inspection, reduce the cost, since it's very easy now. It's very cheap and fast to access to the location with any additional infrastructure or equipment, and also reduce the game creators. It's not here, but also you increase the safety of the operation a lot. You don't need people to work at height. And the navigation system, of course, this navigation system, the wearable, is not linked to any particular drone manufacturer. So you could install you could adapt it to any manufacturer. So I think we can see. I think that was all for it. So let's see if people have put some comments. Here are some comments. Put a little bit of more. Yeah. So there's one comment saying that, for example, here, super high value proposition that can invite the private operator use to hire the assessment inspection to 3D parties. So a general open framework is flexible. Okay. So I think Miguel is working on that. And Natalie here is also saying that that the fact that the system can inspect the same location by following the same coordinates is very useful. Still, in case of inspecting overpass, traffic below will still be, yeah, this is an important thing that about the safety and having traffic below and so on. Yeah, but it's true that even if you cut the traffic below or stop it, the idea is that you can do it much faster. So maybe you need 15 minutes or 20 minutes and that's it. So you can cut for 15 minutes, do the work, and then continue. So that's the idea. So I think, Henry, that we have finished with the general ones, no?
Yes.
Okay. So we are very thankful for all the comments that you are putting on the Miro board. Maybe we can leave a few minutes, a couple of minutes, so people can't, once you have seen the first 5 value propositions, if you can't just add some comments to these first 5, could be very grateful. I remember the quickly build 3D asset model, so you can quickly build a model of the refinery without, or the asset, sorry, the refinery to the asset, so you can easily create a 3D model that can be used for planning or for visualizing the inspection results. Okay, you can put some comments here. The mission planning interface, this is an interface that facilitates the use of the planning of the trajectory, specific trajectory, taking into account the robot restrictions and dynamics, and also the different restrictions of the asset easily. The piloting inspection maintenance platform, this framework, that a set of software that facilitate the integration of robots to transform it into a real tool to perform the inspections. Okay, so you can plan the inspection, then transfer to the robot. You can get the robot data and integrate it into a database which is fully digitalized, and then is geolocalized and linked with the inspection itself, and then facilitate the assessment. Then the robot control station, that you can use a robot control station, the same one for all the robots, reducing the training, and the GNSS free area robot navigation in large areas. So if you can add that we just presented, add some comments in the Miro board. We will leave a couple of minutes before we start with the refinery specific value proposition. Okay, we will. There's Natalie that has commented for the other people. If we can share the presentation, yes, we can share it. And also we will leave open the Miro for one more day, so you can also add some comments later on. Okay, one more minute so people can put some comments on the Miro board. We're very grateful of your comment. Okay, I think that we can move forward. Henrik, what do you think?
Yeah. Yes. So it's moving to the refineries with the wall thickness measurements.
Okay, there's one comment here about navigation for bridge inspection. There's one anonymous. I think you can go just to answer this. There's one. Yeah. I don't know who asked this, but a second. Yeah, I will put here 1 second. So you can check the papers of piloting at Zenodo. I just put it in the answers, and there is a link. So for all of you, there is all public material is here. So you also links to the papers and so on, so you can have a look to it. So let's go to we can move forward. So world thickness measurement by aerial robots. So next slide, please. So again, what is the customer job? So we have to perform the I mean, as most of you probably know, in the refineries, an important task regarding to inspection is to perform thickness measurements using ultrasonic devices, wall thickness measurements. So they need to continuously monitor the thickness of the wall thickness of different infrastructure, for example, in tanks or in any other infrastructure, or in pipes and things like that. So it's important for them to check regularly the thickness of the different infrastructure. What are the pains related to this work? Well, this is costly and time consuming, especially in large infrastructure. You need to create scaffolding structures or work at height, as you can see on the figures at the left. As it happened in the bridge or in the viaduct, most of the time is invested in accessing the area of inspection. This is in order to take the measurement, maybe you need half an hour just to get to that point, or 2 hours, because you have to create the scaffolding and so on, and then or 1 day of work to create the scaffolding, and then you will go to a different position and take the measurements only a couple of minutes. And also it's a dangerous work. It's a dangerous work because it's a refinery, it's a work at height, so it has a big impact on safety. So what is the value proposition that we are developing in piloting? Next slide, please. So as you can see in the video, the idea is to use a very special aerial robot that we have developed that is able to perform this constant inspection using UT measurements directly. So so you don't need to create or manufacture or put a scaffolding. You don't need to work at height. So it will it's much safer and also much faster. Okay. So you will see here how this basically works. So this is maybe you can move forward to the video. To this, yeah, something like that. So you can see that they can't. The aerial robot can't make contact and then do the wall thickness inspection by its own without having to have people working at height. Okay, so this is the value proposition. Okay. Okay, just to give you an idea what we are developing. So what are the gains? Next slide, please. Yeah, so I will answer the question after the presentation. So what are the pain relievers? So of course, the safety risk is highly reduced for the inspector and all the personnel. You don't need to be close to the dangerous area. You don't need to work at height, so it's a double benefit. And also, it's an important value pain reliever is that you don't need to coordinate or to add an extra company or an extra work in the procedure. Like deployment of the scaffolding or the ropes that you need for the rope access and so on. Regarding the game creators, of course, reduce the time, increase the safety, reduce the costs, and the costs since access to measurement location doesn't require any additional infrastructure equipment. So the information, the data for each point, you will require less time and less cost. And also important thing that we are also developing a piloting that is on here is that we can also, as I said before, integrate this information, including the location or where we are getting the different inspection locations into the platform. So you can geolocalize your measurements, and it will not just be the location taken by the operator itself. It will be a fully geolocalized and digitalized measurements. So you can see in a 3D view, you can have a view of the different, of the complete asset of the different locations you have performed the measurements. Okay, so there were some questions here. How often this inspection need to be executed? So this is quite often. I think in a regular refinery, they do more than 50,000 measurements every 5 years. So it's a lot of measurement they need to do. You use ultrasound technology for that, to do this wall thickness. I don't understand the last question of Mohammed. Maybe if you can elaborate, we can comment. So please go to the mirror board. Okay. And we are on the second row, frame 6. There are some people here. Yes, good. Here, frame 6 is on the top of the second column. Okay, you can see my name and Tidio here. And you can put some notes if you want. Okay, and put some comments, please, in this one. So, sample Cortis, perfect. So we will leave 1 more minute before we move to the next one. So there was more questions. The geolocalization of the aerial robot in the viaduct and in the value proposition that we presented for the viaduct and for the tunnel, for the bridges, doesn't require any ground-based system. So we use a LiDAR on the robot, and we use the LiDAR information data to localize the road within the viaduct and be able to also have this global position system. So we can come back to the same. It's true that for the first time you go to a new asset, you need to get a 3D model of the viaduct and you reference it. You can do it with a total station, or you can do it with a drone with a LiDAR, whatever you prefer, or with any other technique, but you need a 3D model that is your reference in a global reference system. But then what we do a matching between the map that we obtain real time from the drone and the one that is your reference. And then with this matching, we can know where the road is in the global reference system. Good. So there, for example, one comment. Yes, so what happens about not ideal is true. We are working, Curtis, in what happens if the surface is not ideal and you need to clean it. No, so we are working that in this N effector that we have on the road, we have some cleaning device, so it can help to do this. So this is something that we also plan to have. We have performed some first prototypes of this cleaning tool, and we plan to test it in in next year experiment, but it's something important. That's true. Thank you. I think it was Curtis. Okay, I think we can move forward to the Henrik, to the next one.
Okay, yeah, we're still in the refinery use case. And what often needs to be done is that flows in pressurized pipes need to be regulated. And since this has a high risk of explosion and other dangers, often these areas need to be isolated before you are allowed to regulate the flows on the handwheel valves. So of course, this means that in general, the time and the cost for accessing the location itself is often higher than the cost for the inspection itself. And this means that the frequency itself is often reduced of the inspection. So, which is quite dangerous, given that these inspections are critical oftentimes. And also, in general, as long as there are humans involved in these areas, there are strong safety requirements. So all the protective equipment that is needed and all the approvals that need to be acquired before humans are allowed to enter such a segment often prevent these inspections to be done that easily. So what we propose instead is to use a robot, an unmanned ground vehicle, that can autonomously navigate in the refinery and drive towards a handwheel valve, and then kind of detect this handwheel valve using a key point detector. So the advantage of using this key point detector is that it can detect a large variety of different valves with different number of spokes with only one training phase. So essentially, you don't have to tell details about the valve type. It can infer more or less different type of valves already with a good prior training. And then it can manipulate the valve compliantly, as you can see in this video. And the advantage of this is that even if the detection should not be that accurate in the first phase, it will still not damage either the robot itself or the valve. So it's quite a safe operation as well. And yeah, so now when we look at the pain relievers, we can see that exactly the risk for the human personnel is reduced by using the robot. And this also means automatically that more frequent inspections can be conducted without additional costs. Looking at the gain creators, we now don't have to consider additional operator safety measures. So only the robot needs to be safe, and then no additional measures need to be considered every time. Also, on top of that, since we are using a torque controlled robot, we can gather quite a lot of inspection data while doing this. So for example, the handwheel reaction torques are measured while the robot performs the task. So this allows, for example, to detect when a valve gets corroded or is stuck. Then this can be seen quite easily in the curves that come out of the measurements. So this allows already to do preventative maintenance in a sense. And also these protocols can all be conducted without having to have the operators on the refinery itself. So yeah, that's for the valve turning use case.
Thank you very much, Julian. So we are in the frame 7, okay? So if you can, I can see some comments here. Let me check. People are writing, that's very good. Thank you very much. For example, this one regarding the accessing pipe areas used to be difficult, wheel-based robot might never reach these areas. That's true. This is something that we are working on the project. There are, I would say, we are working on 2 ground roads, and one has a more mobility. But it's true that it's something to take into account. Thank you. Also here said about torque data, a long time will improve a lot the maintenance works. So that's also, thank you very much. That's very interesting comment. And the torque information is good at valve handles generally get says and require a lot of torque initially to break the initial movement. Okay. This is thank you very much for the comments. So maybe we can leave 1 more minute. So if people can't comment or think a little bit about it. So thank you again very much to everybody to put your comments in Miro and to give us feedback about each of the value propositions. And please don't forget that we have 3 more to go, and then we'll have a survey, so you can help us to identify the most promising ones, okay, that we plan to even develop further in the project. So please stay until the end of the workshop. I think we can move to the next one.
Yeah, so now we're moving to the viaduct and tunnels part of the presentations. So installation of surveying targets using aerial robots. I think it's Maria.
I'm here. Hello, everyone. I'm Maria from the University of Seville, and this value proposition is related with the inspection maintenance tasks that are
Maria, we cannot hear you very well, I think. Maybe you can turn off the camera.
Perfect. It's better now?
Now, yes, it seems so.
Okay. So next, Henry. So the main inspection carried out in bridges and viaducts are visual inspection to detect possible defects or the destructions, and also for the improvement of these visual inspections, some surveying targets are installed to measure the depth of some cracks and defects. And the process of manually installing the targets includes in some that are, for example, that this kind of inspection is causing in big cost and time due to the heavy machinery that is required to the access to some location at different heights and that are difficult to access, and also increasing the age of the personnel that perform this inspection. Next slide, please. So our objective is to relieve pain by using aerial platforms to perform the inspection of targets. The technology always taking into account having in mind that the target that we used are the ones that are using real inspections in order to approach the developed technology as much as possible to a real solution. They are the ones you can see on the left, and on the right you can see the representation of the full mission. So the robot takes us from a safety area, and the inspector decides which of the previously detected defects by visual inspection should be selected and inspected. And the UAV will navigate to an approach point in front of the first selected spot, and then the robot will start to the approaching maneuver. It make contact and attaches to the pillar. It will then install the surveying target, applying enough force to stick it on the surface, and next it will detach from the pillar and return to the approach point. And then if the operator wants, it is ready to continue the mission, installing more surveying targets. Next slide, please. Here you can see the air robot we have developed from scratch. I would like to highlight that with only one robot, we can perform not only surveying, we are able also to do the visual inspection, and we are able also to install some wireless sensor, because one of the requirements of the project is we should design a platform that can fulfill with 3 different use cases in a viaduct. So here in particular, we are showing you the contact and effector that we use to install the target, and the target is placed with a touch and go maneuver against the wall. Next slide, please. Here you can see some pictures of the installation of targets with aerial robot. It's a real mission that it was conducted in a real viaduct here in Spain. You can see how the robot navigates, develops the approach to the pillar, and makes the contact for precisely installing the target. The drone navigates to the point of interest previously selected by an operator, and this point could be different heights. And we have demonstrated that we are able to install and survey targets in only one mission, taking a total time of about 15 meters for the installation of 3 tasks, and addressing real industry tasks related with the inspections. And also I would like to highlight that we are obtaining some information and background from some end users of the project. They are expert in performing maintenance and inspection tasks in viaducts. In order to compare the measurement we are obtaining with respect to the traditional methods, they are giving us some reference about the method that are used now with the traditional methods. Next slide, please. So, as the main pain relievers, the time required to install the target is drastically reduced. As I have mentioned, we are able to targets in about 15 minutes, and we are able to reduce the accidents of the operators due to the tasks that are performed at different heights. And as gate creators, we reduce the time to standard surveying targets, as I have said. We reduce the cost derived to the difficulty of access to the target installation location for the operators. We increase also the precision of the location in which the surveying targets are installed due to the localization system of the robot. And also, that is very important, the safety of the full procedure is widely increased.
Thank you very much, Maria.
Thank you.
There was some cut, but I think people were able to follow it. let's give the people a few minutes. We are in frame 8, so it's the second column, okay? And so please, if you have any comments, anything that you can add, please put a note in the mirror one, so that it could be very good. And we will leave a couple of minutes so people can do it. Again, if anybody would like to comment on any other value proposition, please do it. For example, I can see on the one of the autonomous hand well valve detection manipulation, is that only visual, only audio data? Is screeching valves, for example, that's interesting. Accessing pine areas to be difficult. This is already commented. Okay, so you can please remember that you can add to any other. For example, there is a comment now on the installation of survey targets. Natalie, let's wait that she can finish. Okay. Make surveying of bridge deformation much easier to execute. Make survey, for example, bridge deformation much easier to execute, both in terms of time, but also in terms of planning and safety. That's good. So I think you like it. Thank you very much. Okay, we can't leave 30 more seconds, but I think we can start moving to the next one. We have two more, okay, two more to go. So the next one is a value proposition about artificial intelligence for defect detection, classification, and segmentation.
Okay, good morning from my side. Yes, for sure we will see the value proposition, which is a joint, let's say, activity that it is primarily is developed by ICCS and UC. Next slide, please.
Next slide. Yeah, perfect.
Oh, okay, thank you. Okay, if we want to see the value of our solution, for sure we have to begin with the current state regarding the inspection and the maintenance process that it is usually performed for the concrete infrastructure like the viaducts and the tunnels. Regarding the inspection process, we know that it is a procedure that is usually performed by a team of the corresponding transportation authority or some external service providers. Also referring to the personnel that is dedicated to perform this inspection process, we can see that it is usually performed by visual inspection or by or then the evaluation of the observation is done. It is based in empirical, let's say, judgment, and in sometimes they also use some sensor applied methods with some manually operated machines, with the most common to be the ground penetration radar. Next slide, please. Okay, referring to the aforementioned activities, we can say that the main customer pains and challenges are that normally because it's a manually performed process, it is usually a resource consuming operation. It is tedious sometimes, often will be completed or it will be completed by 2 or more teams of personnel. And also there is, we found across the literature that in fact there is an absence of holistic inspection procedure or a training procedure in order to apply common steps to perform this inspection process. Or to, regarding the data collection of the defect detection. And also, for sure, we have identified that the classification or the detection of the defects, it is prone to inspector subjective judgment and maturity level. Also, a common issue is that during the inspection, normally they close some transportation lines. So the personnel is potentially experiencing some safety insecurity, let's say, because they're in the middle of roads. Also, they found difficult to perform the inspection in remote and difficult accessed areas. For sure, because it's a manual process, it is a time consuming, and also the analysis of the collected images, it also takes time. And of course, because of the absence of generating some specific this information under some specific instruction, and sometimes this information is prone to be lost. And of course, there are the expenses of this manual process is higher than the automatic one. Next slide, please. Can you hear me? Okay, thank you. Okay, collecting all this pain and this space, this remains space for improvement. What we have built is an artificial intelligence defect detection, segmentation and classification solution. As you can see on the left, it is based either in open access datasets, and also it receives data gathered from the robotic systems like drones or cars, and also it is based in three let's say tiers, with the first one to perform an anomaly unsupervised detection, which is dedicated to determine if an image is unhealthy or not. With the images that we found a defect, we are moving towards the second component, which is the tile-based defect classification, where we are able to detect the different defects, like the one that you are seeing on the left side, the cracks, the spallation, the rebar exposure, scaling, and segregation. And then we can even go to a pixel level, where we can find the actual size and the area of the defect type, and also concerning the cracks, we can also extract information about the width of the crack, the height, the orientation. We think that it is important because when you monitor continuously this kind of problems, you can find also meaningful information regarding their temporal evolution and perform some dedicated mitigation measures. So next slide, please. I think we have some delay.
Enrique?
Okay, thank you so much. So what is our pain relievers of our solution, or in general the benefits. For sure, we can reduce, sorry, one later. Thank you so much. Okay, for sure we can subsequently reduce the effort that normally is required by personnel to either to collect and validation the health state of the inspection of the infrastructure. Sorry. Of course, we can reduce the time and cost for inspection and the presence of inspectors in damaged regions, because we believe that the involvement of personnel will be complementary, and in terms of let's say validation, the quality of the results after the implementation, but remotely. By performing a remote inspection, not on site. Of course, we are able to identify different defects and their types. As I said before, some characteristics of the cracks, like the length, width, and the orientation. And of course, due to the standardized provision of this information, of the collected information, of course, it will be possible to generate an inventory data set, which can be used for a long-term management of the infrastructures. And that's all for me. Thank you for your attention.
Thank you, Katerina. Thank you very much. So, so as we have seen, we are in the frame 9 in Miro. Okay, so I hope you were able to follow the presentation, and please add your comments. We're in good timing. Okay, we only have one more to go, but then we have a survey, so please stay with us. This is an important survey for us. So we will leave 1 more minute so you can put some comments on this value proposition. We are at the bottom, almost bottom part of the second column in the Miro board. So there's already some comments. Okay, at least one. Some for Natalie say safer, faster, and cheaper visual inspection. Could it also incorporate a way of measuring crack depth with some additional equipment? Yes, of course. I mean, the idea here is to use this technology for this first, I would say, general inspection. So you can grab a lot of images, the complete tunnel or the large part of the viaduct with a large set of images. Then once you detect something interesting to the monitor, you can go with another type of robot specifically. For example, the one that we show before with the ultrasound measurements, and maybe you with some ultrasound measurements you can measure the depth of the crack, or even maybe in that sense you can go with a person and do it manually. But of course it will be a second phase. This is a more general inspection to detect this type of failures, and then the depth you need some specific devices for that. Then please, if you need you have any other comment, please put it. As the Miro board is open, you can also comment one beforehand that you maybe have been thinking about a little bit. So you can also comment on other ones. Okay, Henry, I think we can go to the last one.
Yes, so that will be presented by me, and yeah, I think we have had some issues with the quality of the Zoom meeting, but I hope this will work fine. So this is about navigation in tunnels where you don't have access to GPS, so therefore you need to have a different solution, and we will solve this using an onboard sensor module. So this is when you go into a tunnel and do an inspection, and you need to report the location of damage or some other point of interest, and you upload this location to the inspection platform as a metadata, and then you should be able to find the way back to this point of interest, which then will be indicated in a mission plan. And we want to do this with a high precision, so the goal is to reach below 10 centimeters so that you can find it again. And since we don't have GNSS, and the structure in the tunnel is a bit difficult to actually find something that you can characterize a location, and you have problems with also the magnetic fields that is not really reliable. So this is a bit of a challenge. So one solution then is you can use some external positioning system, which of course adds some cost and effort, or you will have to settle with a lower accuracy. So for example, using something like emergency telephones to try to indicate the location of damage, and then you get a very low resolution. So the value proposition is to use this sensor pack on an inspection vehicle. So this is the cart vehicle from Robotnik, which this sensor pack is integrated into. So then you can use the sensors to do the localization. So we have a combination of LiDAR, IMU, and a camera suitable for low light conditions. And all these sensor data is then synchronized and used for the location algorithms. So it's a sensor fusion from the LiDAR camera and IMU. And it can do basically both the localization and the mapping, but we're mainly focusing on the localization. And this can then be integrated on a vehicle that can either be like a traditional manually driven vehicle, where you get the benefit of having the data tagged with an exact location. And it can also open up for autonomously driving vehicles like the one from Robotnik that can do the inspection autonomously in a tunnel. So the pain relievers is basically then that you do the positioning without the need for any external systems, which will reduce the cost and the effort of doing the positioning. And you also have this gain of having a much improved accuracy in the positioning. And you have everything on board in the vehicle once it is integrated. Yeah, so that's the short presentation of the navigation in tunnels. So can leave you the time to go and comment in the last frame in the mirror board. And thank you for the attention.
Okay, thank you, Henrik. So we will leave a couple of minutes to comment on the mirror board. Okay, this is the last one. Okay, it's in the second column, so you can put to the navigation. Also, if you have any question, that could be great. Okay. So I think we can leave for 1 more minute. And then please stay with us. We're going to start a survey. Okay. And this is a very important survey that will allow us to classify all these value proposition. Also, if you have any questions about any value proposition, you can share with us using the chat or the question and answers. So this is also important that please comment to us. Okay. So we'll leave a couple of more minutes and we can then. So let's check.
And the mirror board is basically open, so you can continue.
Yes, yes, of course. If you want to comment anything in any other value proposition that was previously presented, could be great. So just remember the last 5. There were 2 about the refinery, the wall thickness measurement by aerial robots. Remember this robot that can do ultrasound inspection of wall thickness, saving time, increasing safety. The autonomous hand well valve detection and manipulation, the use of a ground robot for hand well valve manipulation in autonomous way. The installation of survey target by aerial robots, the use of aerial robots to put targets on the viaducts or the bridges or any other infrastructure at height, also saving a lot of time and cost, increasing safety. And the AI-based defect detection, crucifixion, cementation, the use of AI-based algorithms to be able to analyze a large number of images looking for defects, different type of defects. And the last one, the navigation engineers, the night tunnels that was just presented by Henrik. So we presented this 10 value proposition. Of course, we are developing other technologies in piloting project, but these were the ones that we think can have more impact, and we need your help in order to complete the survey. That please, Jose, can you put the link of the survey on the chat?
Yes.
Thank you very much. So please, all of you, the attendants, we have all the different attendants that we have. Now Jose is going to copy the survey link on the chat, so you can go to the survey and classify the different value propositions, whatever you think they are more interesting.
May I share the QR link, Divio?
For example, or the link directly. Okay. No, you don't have the.
Yes, it's already on the chat. The link. May I share the presentation for the?
I cannot see it on the chat.
For the results.
Have you published in the chat? I cannot see it on the chat.
I'm sorry. 1 second.
Perfect. Now
I'm sharing there directly to you, Dantidio, because I'm not able right now to share on the chat. So please, if you can do it.
no, it's already okay. Cannot do it in the chat. Okay, I'm going to do it to everybody. Okay, so now here I think you can see it. We can leave so for I don't know who was Carlos Cuevas. Okay. Yes, if you think that you have other colleagues that may be interested to complete the survey, that could be great. The only problem is that if they haven't attended this workshop, it's going to be difficult for them to understand what are the value propositions. So if you click, okay, on the link, I think everybody is able to do it. Okay, so you have from 1 to 10, Jose, and 10 is the most promising one, and 1 is the less promising one, no?
That's it. Yeah.
Yeah. So I'm going to share just the screen. So you should see something like this. Okay, everybody, all the attendants, you should see something like this. It's in the link on the chat, and just check what is the value proposition that you think is most promising. Okay. For the general ones, the refineries and the tunnels and viaducts. Okay, and once you are done with all of them, you just need to click. For example, you say whatever 10. So 10 is most promising one. 1 is less promising one. Okay, so this is less promising. This is most promising. And once you are done, you just click the last button, and we will get all the information. So we will leave 5 minutes for everybody. Okay. If anybody finds any problem to complete the survey, please send put something in the chat. I think it's just there is one just per question. I mean per value proposition. So for each value proposition, Natalie, you have to select a number. But for each value, but you have to answer for all the value propositions. Okay. So I'm going to share again. I think maybe this is easier. So for example, you say for quickly building 3D asset model, you say, oh, this is interesting. Let's put a 7 or an 8. Okay, what is happening here? Sorry. But then you cannot put 6 and 8. You put a 6 or 8. But you can put here an 8, here a 10, here a 6, here a 8. So you can answer all of them, but only one per answer, per value proposition. I hope this clarify. Oh. Okay, so maybe you can do again. Okay, we will try to. So if you can do it again, if you did that, one was the most promising. That's it's going to affect some, but if you can do it again, that could be great. So maybe we can try to use this information. Okay, so you can answer again if you want.
We have 11 answers so far, Antidio. So just for you to know.
Perfect. Thank you very much for all of you. Maybe I'm going to put the link again. Okay, not to everybody, sorry, everybody. Okay, please, let's try to get until maybe 20. So all of you, if you can answer the survey, we will be very grateful. It was very good workshop with the Miro tool to get your feedback. It's not easy to get this type of workshop with so many people, so it was very good. So we will leave a few more minutes, and then we will show you in real time as well the results. So if you stay a little bit longer, okay, 10 more minutes, we will be able to show you all the results of the survey. I think this could also interesting for you to know. How are we doing, Jose, with the answers?
15 right now.
15 right now. Please, some of you, we're going to leave 2 more minutes, and then we will close the, at least we will put the result that we have so far. So 2 more minutes, and we will check the results, and we can present to everybody. And please remember that the mirror board is also open, so you can put extra comments if you want. We'll send the slides as well, so you can add more comments in the next days if you are interested. So let's 1 more minute, and we can go to the present. We can close, and then we can present the results. Okay, Jose, how many answers do we have?
18.
Okay, I think this is good enough. So we can you can start processing the information.
Okay.
And then you can please
I'll
comment to us when you are ready. Okay.
I will download the results. Yeah, give me just 1 minute.
Okay. So okay, we need to wait a couple of minutes, but again, I would like to thank all of you for participating in this piloting innovation workshop. I hope you find it interesting. That was a good overview of the main technologies that we're developing, how we think this can impact the inspection and maintenance sector. We are very grateful about your comments using the mirror board, and also about completing the survey. It's an important aspect for us to guide us in which technology we should focus more, and also to work on the future exploitation plans. Also, we are sorry about some technical issue that we had during the workshop, some sounds and video problem, but I think it was good enough to follow the presentations. And as I don't know if you are aware, but we have a piloting user group. So if you are interested to participate, just send us an email to the piloting email. Okay, I will put in the chat. and just send an email and we will put you in the piloting user group. This is piloting user group sends updates about the project. It's very helpful also to know what is happening, to receive the newsletters, and also, of course, to be aware of the workshop that we organize. So piloting project at Catec Aero, as you can see in this in the chat. So just send us an email if you're not part already of the piloting user group. Also, just to comment all of you that we are also plan to open source the piloting inspection maintenance platform next year. So if you are interested in this, in the open source version of the piloting inspection maintenance platform, please send us an email and we will keep you updated. If you want to be one of our beta testers or you are interested in one part of the piloting inspection maintenance platform, please send us an email and to the same email, and we will keep you in the loop and keep you updated about the open source part. So I don't know if just Jose, tell me when you are ready. Okay, we are analyzing downloading the results of the survey, and then we will shortly present to all of you.
Almost done.
Thank you very much. Also, I would like to thank all the piloting project partners that help us to organize this workshop, especially to Henrik and also Catec team, Maria Jose and Jose, that were able to organize all this, and of course the rest of the partners that help us to present their technologies. You know, they are the experts and they are the best one to present it. So that's very good as well. Okay. And as I mentioned by chat, we will upload we are recording the session. We will upload it in the YouTube channel. So we will send through the piloting user group the session recorded, and also we will send to the participants of this workshop the presentation as well. So, Jose, how are you doing? Okay, 1 second. I'm going to put you at good. Now you should be able to share your screen. Okay.
Yes, thank you, Antonio.
Okay. If you have problems, I can also open it.
Can you see now?
No. But let's see if I can open it. Okay, so let's just to conclude the workshop, and sorry for this delay. So you can see here, okay, the voting. So there was this after the recollecting of all the voting. So we have the different value propositions, okay, that were ranked. So it was the IE-based effect detection, classification, segmentation, ranked first. Installation survey targets, second. The generic robot control station, third. The piloting inspection maintenance platform, fourth. The mission planning interface, fifth. And the work thickness measurement level, six. And then we have the GNSS free robot navigation in large areas, navigation in tunnels, using onboard modules, the quickly building 3D asset models, and the autonomous hand wheel bad detection and manipulation. So thank you. That was the ranking. So thank you very much for your for participating in this workshop, piloting innovation workshop. I don't know, Henrik, you want to say something else?
No, I just want to say thank you as well. It was very useful comments and feedback. Okay. And well, the Miro board is still open if you want to make some additional comments.
Perfect. So just in time. So thank you again, and we'll keep in touch. And thank you for participating. Bye, everybody.
Bye. Thank you.
Bye. Thank you.
Bye.
Bye.
Bye.